Hey, hello everyone. So today we are going to solve this LeetCode problem 213, which is house robber 2. So this is an extended form of house robber problem which has a circular dependency. Let's jump into the question. So you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. All houses in this place are arranged in a circle. That means the first house is the neighbor of the last one. So the first house is the neighbor of the last one. So it's a circular kind of. House number one was that where is a linear form of arrangement of houses. There is no circular dependency. The last house is not the neighbor of the first house. Okay. So that means the first house is the neighbor of the last one here. And meanwhile, adjacent houses have a security system connected and it will automatically contact the police if two adjacent houses were broken in the same night. Alright, so given an integer array nums, alright, 234, 232, representing the amount of money of each house, return the maximum amount of money you can rob tonight without altering the police. So, maximum amount of money would have been 2 plus 2, 4 if it was house robber 1 problem. This is house robber 2 and the solution to this problem will be 3 because the first house is neighbor to the last one. So this is the turning point of this question, and coming to the second example, how rob house 1 money 1, then rob house 3 money 3. Total amount you can rob is 1 plus 3, which is 4. So alternate without messing up with the last one. Okay. So jumping to the solution to this would be somewhat similar to the house robber one. A slight difference would be that we would be creating a method which will be called twice based on the parameters that we passed and to make sure that the circular conditions are taken into consideration. So here it will be suppose I will be returning the method execution, which will be rob house, and that will be under method max value. I'll be calling 2 times this method rob house, and which will eventually be in this terms that once I will pass the nums array with initial value as 0 and with last value as nums dot length minus 2. And if I take the consideration of not the first element but the second element, in that case I can the parameters would look like something this. The start value is 1. So if I'm choosing the first index, which is 2 value, then the loop will go till um, that will go to nums dot length minus 2, which is this only. But if I'm choosing the second element, then the loop will go till nums dot length minus 1, which will be this element. The same logic will go here. If I'm choosing the first element, the loop will go till nums dot length minus 2, that is till 3. If I'm choosing 2, the length will grow to till the last one. So to avoid this circular dependency situation. All right. So here the nums dot length minus 1 would be the last parameter being passed, and then we will create this method which will be of int return type, and which will contain int array of nums, and the starting int start and int end, which will be the values int start, int end, and int array of nums. All right. So here we will obviously this is a DP problem, so as happen to be, and the DP problem usually consists of a DP array being defined, a general protocol. DP is a new int which will be the size of end minus start plus 2. The reason why plus 2 is because we always have the initial values in DP considering the 0 index. So when no house is there, the amount dropped is 0. When one house is there, the amount dropped is nums of start, whatever the start value will be. And if there are multiple houses such that int I is equal to start I is less than nums, which is the end, and I plus plus. Alright, so here the thing is that the end is basically inclusive of the last index, so it will be less than equal to n. And here, as we use the logic of house robber 1, which is dp of I is equal to math dot max of dp of I minus 1, or nums of I plus dp of I minus 2. Alright, and usually we do this and we return the dp of n minus start plus 1, which was the n minus start plus 1, which is the last index value. So this is how it goes, but there is a tricky part here, is that if the start is 0, it will be less than equal to the end, and dp of 0 is equal to math.max dp of 0 minus 1, which will be negative, which will be index out of bound exception. So how is we are going to handle this situation, which is a different scenario from house robber 1. So here we have to think of something, how we can manage with the parameters being passed and start and end. So we have start. All right, so start is something, so we always have 0 and 1 value being already in the dp array. So we can start from the third position, which is 0 1 2, second index position, third element in the dp arrays, and start I is equal to start plus 1, and now this is I, and now this ith value will be I minus 1. Okay, but now suppose the start value is 0, so I is still 1, and again dp I minus 1 will be correct, but I minus 2 will be index out of bound. So how are we going to handle this situation? We already handled this situation. Now the situation here, index out of bound, would be for this condition, dp of I minus 2. So we can handle it with start using if the start is 0, we can say something like dp of I, which is 0 1 2. We want 2 at this position, so I will be I minus start plus 1. The start is 0, so I minus start 1 minus 0 is 1, 1 plus 1 is 2, so here it comes dp of 2, which will be math.max of dp of um, dp of I minus dp of 1. We want 1 here. This is 2, and we want 1 here, so which will be I minus start, which is I minus start is 0, and 1 minus 0 is 1, and 1 minus 1 is 1 minus 0 is 1, and 1 minus 1 is 0. So dp of 2 is either dp of 1. We want 1 here, so dp of 1 is dp of I, or dp of or I is basically start plus 1. Okay, or dp of or nums of I, which is start plus 1, plus dp of I minus start we have to be on, I mean dp of 2 here is either 1 or 0 plus 1. dp of I minus start minus 1. So let's check dp of end minus start plus 1. Okay, this has to be returned. Why it was not throwing error at first? Okay, this is accepted, and this is failing at the boundary condition, which will be the case that if nums of length is equal to 1, then you have to return nums of 0. This is the boundary condition. Wrong answer for output 220, expected 340. So if nums thought length is 1, then num thought 0, else return math.max. Okay, this is output 220, expected is 340. 220, and it is 340. It should be 200 plus 140. Okay, there's something wrong here. So the condition here is simple. Rob House method is correct with nums 0, nums of minus 2, nums of minus 1. This sizing is correct. 0 and 1 is correct. I is equal to start plus 1. Start is which could be 0 or could be 1. It will be the next index position from there, and then we will go backward, which is 0 or 1. So I minus start plus 1. So it will be I minus start 1 I is 1, 1 minus 0 1, 1 minus 0 1, 1 plus 1 2. The dp of 2 is basically start plus 1. dp of it should be always start plus 1. It's a static value. Something is wrong here. So dp of 2 would be either dp of 2, dp of 1, or dp of 0 plus this current value. dp of 1, how I can get dp of 1, which could be to go backward, I minus start minus 1, I minus start plus 2. Have to think of like dp of I minus start plus 1, or so the thing is simple, that this is I minus start plus 1, which is 0, and I have to go, which is not 0, which is 2, and I have to go, for considering this case, I have to go 1 and 0. So 1 will be this. How it could be 1? I have to think of how I can have 1 here with the dynamic values. So I can have here 1 as I minus start yeah, I mean it is 1, and I minus start will be always 1. I minus start we always one step back, and then this will be this is correct, I think. Yep, so this was the thing, and the tricky part was with playing with the start variable here, and this is how we're gonna end up in interview questions and trying to brainstorm at certain condition check. This was not a lengthy problem, it was a short solution, and the tricky part was with playing with the start to variable and thinking of something that calling the Robhouse method twice, creating a Robhouse method and calling it twice with based on restricted length of the array, which thus handles the circular dependency. And in this way, this problem is being solved. Thank you for being at my channel. See you in the next problem.